Extreme Control Center is a rich integrated network and inventory management platform providing centralized visibility and control of enterprise wired and wireless network resources. Extreme Control Center uses a distributed client-server architecture that is primarily based on SNMP and is displayed via OneView, a web-based single pane of glass interface.
Extreme Control Center Network Management Database contains device models that represent actual physical devices. The database models contain attributes that map to the actual device attributes, or SNMP MIB objects, and allow for the states of these attributes to be polled for a particular device and stored within the database model. Visualizing the current state of a particular device can also be thought of as examining the database model of that device.
Network device discovery by IP address range is presently supported only in the legacy NetSite console application. The IP address range discovery function creates a list of all devices detected by the console application and allows the administrator to select which devices are saved to the network management database. Within the Extreme Control Center OneView application, the current functionality allows for devices to be added individually. Each network device can be added to the network management database by supplying the unique IP address and SNMP credentials. Each device that is added to the network management database is assigned a particular device profile. Each device profile determines the underlying SNMP credentials for that particular device. Network devices that do not support the SNMP protocol can also be modeled as simple ping-only devices.
Topology maps are created in OneView with the assistance of link and device discovery protocols such as LLDP that aid in the creation of these maps by automatically identifying and drawing the physical links between network devices. It is necessary for the link layer protocol to be enabled on each device within the infrastructure for discovery to take place. Once the appropriate devices have been discovered, a network administrator can arrange the corresponding device icons in a logical manner that best represents the network infrastructure. Once a topology map has been fully built, individual links can be interrogated by double-clicking on them, causing a link details view to display. Within the link details view, the speed, status, and underlying discovery protocol for the particular link is provided. In this particular example, the underlying discovery protocol is LLDP. However, other industry common discovery protocols such as EDP and CDP are available. Once a topology map has been populated and organized, administrators can easily determine by the green or red color whether the device or link is down or operating in a normal state. Additionally, drill-down capabilities for the devices and links allow for further detailed inspection of the network and its components.
Devices within OneView are not limited to just topology map organization. By default, network devices are also organized into many standard groupings such as by device type and SNMP MIB2 system location. Additionally, custom groupings can be created to organize devices in a manner that supports a particular customer's management requirements. One of the standard OneView group of devices is by device type. The device type grouping mechanism puts all devices of a particular device type into one group. In this example, all of the active device type groups are displayed, and the Summit Series device group is further expanded to reveal a group of 4 Summit Series switches. The ability to quickly isolate and display a group by device type allows for easy organizational mechanism for activities such as device-specific firmware updates.
The locations organizational group is one that is automatically created based on MIB2 system location information. During device provisioning, it is a standard practice to set the system location for each device to a meaningful value, such as by building or floor. OneView then automatically leverages this setting by converting the values into a grouping structure. For example, in this image, 3 devices are set with the system location of Rack 2.
In addition, Administrators can configure custom groups based on other categories such as topology location, for example, DMZ or core network. This type of grouping allows administrators to quickly interrogate a specific group of wired and wireless devices regardless of vendor information or MIB support.
Each device that is displayed within OneView can be queried based on its management information base. Selecting a device presents this device view interface. This interface is a collection of information tabs known as flex views. These flex views represent the most important information or objects known about each specific device type.
Once the device view for a specific component is displayed, the most relevant flex views can be studied. For example, the Device and Module Information tab provides useful information such as ambient temperature and system uptime, allowing for administrators to quickly check the physical health of individual devices.
Selecting the Ports tab provides necessary connectivity information that can be utilized during troubleshooting to trace the connectivity path of specific devices within the network. This Ports display expands upon the topology map by displaying detail about each connected port. In addition, specific ports can be queried to obtain interface utilization statistics.
For each device type, a unique collection of flex views are displayed based on the MIB support available within that device. Additionally, SNMP standards-based third-party devices are displayed within the device view in the same manner as Extreme wired and wireless devices.
VLAN provisioning within OneView allows for the adding, deleting, and modifying of VLAN configurations on Extreme Exos devices. These VLAN functions can be accessed via the Network Details pane in the topology map.
When a specific switch is selected for VLAN provisioning, a wizard is launched allowing for the VLAN devices and parameters to be selected. The first screen of the wizard allows the administrator to select additional switches in case the VLAN configuration changes are to be pushed to multiple devices within the network infrastructure.
Once the specific collection of switches has been selected, the wizard prompts the administrator to specify the VLAN name, tag, and which ports are to be included as tagged or untagged. OneView, as a single pane of glass, provides VLAN provisioning for one or more Exos switches without the need to open individual SSH sessions into each switch that requires the VLAN configuration.
Extreme Control Center provides network infrastructure inventory management functions within the device view screens of OneView. The most critical inventory management functions include configuration backup, zero-touch provisioning, configuration restore, and firmware upgrades.
Configuration backup operations can be performed on Extreme Network wired and wireless devices as well as many third-party devices. Via a right-click, an archive of a specific device can be executed manually, or backup configurations can be scheduled for multiple devices to occur on a regular basis in order to conform with change management windows.
When the device view is open for a specific device, a list of previously archived configuration files is displayed. Any two of these configuration archives can be simultaneously highlighted and their contents compared.
Launching the Compare Configuration button displays both of the selected configurations side by side with color-coded analysis of any differences. Deleted configuration entries are colored red, while updated or new entries are colored blue.
Zero-touch provisioning is, in essence, a function that provides the ability to deploy a new or replacement switch into the network with minimal human interaction required. For zero-touch provisioning to function correctly, all that is necessary is for a simple DHCP option to be configured with the management IP address of the control center appliance. When an unconfigured Exos switch boots up, its first action is to send a DHCP client request that returns a valid IP address, mask, gateway, and the IP address of the control center appliance. Once the Exos switch has received an IP address, it contacts Control Center and is registered in the Discovered tab within OneView devices.
When a newly discovered device has been registered in OneView, it is available for receiving a configuration template. A template can consist of a base level configuration which is normally used for new network devices to provide the VLAN, SNMP, and base level networking information necessary to allow for proper communication and management. If the newly discovered device is a replacement for an existing switch, an archive configuration can be pushed to the new device for quick and easy deployment.
Extreme Control Center provides firmware and boot PROM upgrades. An upgrade can be manually performed on a network device or scheduled for a future time. Once the upgrade has completed, Control Center can alert the network administrator that the upgraded device needs to be reset. Alternatively, there is a Reset Devices After Upgrade option that forces a device reset. Having the flexibility to schedule the time when a switch or a group of switches will be reset allows administrators to plan upgrades and adhere to change management windows.
One of the primary responsibilities for a network management tool is to provide the ability to log events and create alerts for specific important events. The Alarms and Events tab of OneView provides a comprehensive listing of all events, including syslog and SNMP traps from managed devices, as well as audit events from separate components that comprise Extreme Control Center. Based on these events, a host of default alarms can be enabled to alert an administrator when specific events occur, such as network error or component failure. In addition, custom alarms can be created around any syslog, trap, or audit event that is logged by the Extreme Control Center system.
While there are many default alarms that can support a customer's required capabilities, there is also flexibility within Extreme Control Center to create custom alarms. For example, strengthening or initiating a change management plan is a common customer need. Within OneView, there is already an event structure that can be leveraged to support a customer's change management plan. In this example, the default NMS dashboard displays all recent device configuration change events. Double-clicking on one of these events exposes the entire contents of the event. In this example, the change management event originates from the Extreme Control Center configuration backup process. This backup process commonly runs on a daily schedule and compares the last configuration backup with the previous. If differences exist between these two copies, an archive event is emitted and contains the phrase, "Configurations are different."
While the change management applet on the NMS dashboard is sufficient notice for some customer environments, the alerting process can be enhanced within OneView by linking this to an alarm. In this continuing example, a custom criteria alarm with the name Configuration Change Detected, Verification Required is created. This new custom criteria alarm is configured to detect log entries from the inventory category with the phrase "Configurations are different" and to apply this alarm across all devices.
When the next "Configurations are different" event occurs, the Configuration Change Detected alarm will fire. The alarm will be displayed in the Alarms and Events tab with the assigned color-coded severity. While this particular example supports the change management requirements, the process can be extended for all types of events that are forwarded into or produced by Extreme Control Center.
Extreme Control Center provides the ability to configure and manage the Extreme Network's role-based policy on both Extreme wired and wireless network devices. Policy is unique to the Extreme hardware and provides for the configuration of role-based profiles for securing and provisioning network resources based upon the user's device role within the network. Policy is comprised of roles, services, rules, class of service, and domain components that when combined together implement an enterprise's control over their network resources.
A policy rule defines one element of how traffic for a particular network service or application will be handled by a network access device. These policy rules are similar to firewall rules in that there is a traffic mesh component as well as an action. For example, creating a policy rule that will be used by edge clients to access standard web resources would match on TCP destination port 80. Likewise, a policy rule that would be utilized by a server to allow the receipt of web traffic would match on TCP source port 80. The action component for these policy rules determines the disposition of the traffic, with the two most common options being to either permit or deny the traffic. Policy is in some ways synonymous to a traditional access list used in other network devices insofar as both provide a list of rules to allow or deny traffic. One distinct difference is the order in which these rules are processed. ACLs are traditionally processed from top to bottom. A flow is forwarded based on the first rule matching the particular flow. Policy uses rule precedence based upon how specific the rule is. Generally, the more specific rule will be applied to a flow before a more generic one, regardless of where that rule exists within the list of rules.
Class of service provides the ability to give specific network traffic preferential treatment over other traffic. By default, there are 8 separate class of service queues available that can be utilized to prioritize matched traffic or mark traffic so that it can be forwarded in a specific manner. Class of service also contains rate limit functionality that can be applied on a per cost basis. Rate limit functionality can be set to a specific percentage or rate of traffic for each cost classification.
Services are individual collections of rules built in a logical fashion. For example, one of the default services within Extreme Control Center is titled Base Services. The base service is a collection of policy rules necessary to allow an individual network device to utilize necessary basic communication protocols such as ARP, DHCP, and DNS.
Another type of special service that can be utilized is an automated service. Network resources can be defined within policy that contain a list of IP addresses or MAC addresses on the network. Examples would be a list of DHCP server IP addresses or router MAC addresses.
These network resources can then be used in an automated service to automatically create a rule with a specified action. Automated services can be differentiated by the purple icon next to the name instead of the standard green icon. Continuing the example, an automated service can be created for all Citrix servers where TCP port 443 traffic can be sourced on the network and prioritized using an appropriate class of service queue.
A rule serves 2 primary functions. The first is that it provides default catch-all actions for traffic that does not match any rule. The second is by serving as a containment bucket for a collection of services. Once created, a rule can be applied to specific ports on an Extreme Network device, detecting any traffic accessing the port to make use of the rules defined within the services that are assigned to the specific role. More often, policy roles are assigned dynamically to an end system when that system authenticates. The goal in this case is to create specific roles that coincide with groups of users and allow for only the services necessary for that particular role. For example, a guest user on a network may be assigned a guest role that merely allows for the ability to utilize base services as well as have access to the internet, while an IT administrator role will allow for extended services to internal and internet applications.
Extreme Control Center policy domains are the highest order container within the policy tree and are made up of a collection of roles and assigned devices and are centrally managed in OneView. In order for devices to make use of the policy roles, these devices must be assigned to a specific policy domain. Although multiple policy domains can exist within one network, it is not possible for a device to participate in 2 separate policy domains. Although it is common to manage an entire network in a single domain, it is also possible to create additional domains containing different policy configurations. For example, in a medical university, it may be appropriate to create one domain containing the devices within the hospital and healthcare portion of the network, and a separate domain for the university and educational facilities. An end user assigned to a student role could have services that differ depending upon whether they are connecting to a device assigned to either the healthcare or educational domain. Additionally, there may be specific roles that exist within one domain that are not desirable or needed in a second domain. Continuing with the medical university example, the hospital administration role within the healthcare domain would not be contained in the educational domain, as hospital business applications should not exist within the educational network.
The Extreme Networks Ridgeline Network Management product contains powerful CLI scripting functionality for Extreme XOS switches that is now included within the Extreme Control Center network management platform. This CLI scripting functionality allows for many common network tasks, such as creation of a new VLAN, to be performed in an automated fashion across one or more Extreme XOS devices without the need for individual SSH sessions to each switch.
The XOS CLI scripting functionality is accessible in OneView by selecting the Administration tab and then the Scripting application. The initial presentation from OneView is a list of all the default Extreme Control Center scripts that are available to be run against configured devices within the Extreme Control Center Network Management Database. All of these default scripts are written in the tool command language, and their source code is available for perusal. To explore the underlying functionality within a particular script, simply double-click the selected item to edit the contents. In this example, the Create VLAN script is open for further examination.
By default, editing a particular script opens to the content window and displays the actual program code. In this example, the program code to create a new VLAN against an XOS switch is displayed. The key portion of the program code that is important to understand is the metadata start section. The metadata section contains a script title, description, and details about the script's function. Additionally, within the metadata section, the script's runtime input or parameter fields are detailed. For example, in this image, the field VLAN name is defined and set with the default value of Extreme VLAN 1.
Selecting the Overview tab provides a display of all the parameter fields that have been declared within the metadata section of the program code. Within the Overview tab, default values for any particular field can be altered and saved. The updated values are then written back into the program code and can be viewed within the Content tab.
Selecting the Run Script button while a particular script is highlighted launches the script wizard and steps the administrator through the execution process. The first screen of the script wizard allows the administrator to select one or more XOS devices from the Control Center Network Management Database. Each switch moved from the device hierarchy on the left to the hierarchy on the right will be involved in the script execution.
The Device Settings screen of the wizard allows the administrator to update the script parameters for the particular run. In this example, the VLAN name field has been updated to Hospital VLAN 2 and the VLAN tag field to a value of 2.
After the parameters have been updated by the administrator, the wizard prompts for any additional runtime settings and then executes the script against the selected list of devices. The last screen of the wizard displays the results of the script's execution.
Extreme wireless installations can be monitored from the OneView application, allowing administrators to review the health of the wireless access points and controllers, as well as monitor the connectivity of clients using the wireless network. In addition, mapping capabilities in OneView can provide physical location information and signal coverage information to the administrator.
Wireless floor plan maps can be created that display AP placement and coverage. The floor plans also provide wall density information that is used to help determine the degradation of the signal strength from the wireless radio as it passes through the walls. This information is also used to help define the probable distance of a client from a given AP. If an Ekahau site survey was performed and saved prior to the map creation, the resulting Ekahau maps can be imported into the wireless floor plan maps. If multiple maps were created in Ekahau, all the maps are combined into a single zip file, and when imported, each Ekahau map is recreated as an individual map. When creating a floor plan map, multiple properties need to be set in order for accurate reporting of signal strength and client location. These properties include environment types such as open space, office cubicles, drywall, and brick walls. Map image formats that can be used include PNG, GIF, and JPEG. A parent map, which is a link to another map in OneView Maps, provides a hierarchical representation of maps. For instance, a geographic map of Building 1 can be created and then linked to a Building 1 Floor 1 wireless floor plan map. The AP height. The AP height is measured in meters and is a critical component for ensuring data.
Once a floor plan is created, the map scale should be set using the drawing tools. If the scale is not known, a helpful reference is that a standard doorway is typically 3 feet wide.
Once the scale is set, the interior and exterior walls should be defined. The drawing tools can be used to specify wall types, thickness, and materials. For instance, a wall can be drawn that is made from drywall and then is connected to glass. The different material types provide critical information for reporting wireless signal strength.
After the walls are drawn, APs are added to the map in their appropriate areas. Lastly, the AP orientation needs to be set to wall-mounted or ceiling-mounted. Once this information is completed, the wireless map is complete. Within a wireless floor plan map, a physical area can be drawn that can be used by Extreme Identity and Access Control to apply different levels of access. This is similar to a geofence where a client enters the location drawn, a different level of access can be granted. For example, in a stadium, a VIP area can be drawn that will grant the client a higher class of service than the standard user. Within an area, up to 16 sub-areas can be defined per floor plan. When creating an area, the depth parameter is used as a unique identifier. In the event a client is located in a location shared by 2 areas, the client will be displayed in the area with the higher depth value. For example, in this picture, within the working area exist 2 other areas, the developers area and the exec area. Since the area depth of the latter 2 areas are higher values, a wireless user will be assigned access built for those specific locations when entering the area.
Client location is determined by using triangulation. Once access points are added to a custom floor plan and saved, a copy of the floor plan is sent to each controller in the deployment. The location engine, which must be enabled to support this feature, incorporates information defined in the floor plan data and signal information from a client's contact with APs in order to calculate a client's precise location. Client information from within a short time frame must be reported by at least 3 APs in order to determine a client's triangulated location. Location accuracy can be enhanced with the addition of access points configured in Guardian mode. When accessing the location maps for a particular client, a colored distribution of location confidence is shown on the map, with black being the highest confidence, red being medium, and yellow being the lowest confidence.
If the location is based on only one access point, the map displays probabilities for the location but with a few differences. In this example, no client icon is displayed. The location confidence distribution area is larger and generally displayed in a circular pattern. In addition, the AP where the client is connected is highlighted and the distance is shown beside the confidence legend at the foot of the map.
If there is insufficient data to provide triangulated results, the map displays the AP in the center, with a circle showing the possible area where the client may be located, based on the client's received signal strength.
After a floor plan is finished and saved, the map is ready to display wireless coverage information. The maps can be used to present signal strength, channel coverage, data rate, and location readiness. These representations can also be displayed by desired band, 2.4 GHz versus 5 GHz, particular channel, or specific access point.
RealCapture allows real-time collection of access point traffic for troubleshooting and problem resolution. RealCapture collects traces on AP wireless or wired interfaces and transmits the traces to a Wireshark installation running on a local client. This functionality supports all Wireshark features, including filters and I/O graphs. It allows Wireshark to capture wireless traffic as if it were running directly on the AP, providing visibility into network connectivity and performance. This feature is especially useful for remote environments where physical access is limited. Enabling real-time capture can be accomplished via a right-click on the AP in the floor plan map.
Upon right-clicking an AP, a message appears to show that real capture has started and provides a CLI command on the host system where Wireshark is installed to launch Wireshark against the AP and view the captured traffic. Interface Wi-Fi 0 will display all the airframes, including beacons, management frames, and data, on the 5 GHz radio, while Interface Wi-Fi 1 will focus on the 2.4 GHz radio. Taking a trace on interface ETH0 will show all wired packets which traverse the access point.
Extreme Control Center provides both real-time dashboards and trend reports through the OneView Network Management Interface, covering both wired and wireless infrastructure devices.
There are multiple default Extreme Control Center reports that can provide real-time views into the network infrastructure as well as an overall dashboard. The NMS dashboard is the primary network dashboard and presents a collection of applets displaying the status of critical devices and network management functions. Additionally, individual applets can provide drill-down capability to expanded information and details.
In addition to the primary NMS dashboard, there is a large collection of embedded reports available to the network administrator. For example, in the reports hierarchy, under the interface category, there are numerous reports focused on bandwidth, utilization, availability, and power over Ethernet. In this example, the top interfaces by utilization shows the breakout of the top 10 network interfaces in grid format and a time series chart of the interface with the single highest utilization values.
Extreme Control Center leverages specific system and custom reports as templates for use within PDF formatted trend reports. The Scheduler tab within the administration screen of OneView provides the ability to schedule a trend report using an existing report as a template. Reports can be scheduled on an hourly, daily, weekly, and monthly basis, and the resulting PDF output can be sent via email to one or more users.